Good morning, everyone. Thank you for joining. This is part 3 of the presentation regarding Kubernetes on microservices. Let me start presenting and we can get going from there. Let me know once you can see my screen. Just a second. Okay. Are you able to see the presentation?
Yes, I'm able to see.
Okay, so in this presentation, we're going to jump more into Kubernetes objects and workloads. Just a second, let me minimize this to get a better view. Okay, just before we start, a little bit about myself. If you haven't attended before, my name is Ahmed Harb. I have over a decade of experience in areas like Linux system administration, cloud, DevSecOps, automation, containers, and microservices. I'm the founder and owner of Code the Cloud. I also work through Object Sharp as a senior cloud and DevOps consultant. Object Sharp are Microsoft Gold partners. I've added links to my LinkedIn profile if someone would like to reach out for any questions of any sort. Okay. I'll begin with a quick recap of the last presentation. In the last presentation, we delved more into what is Kubernetes. And as a word, it pretty much is a Greek word that means helmsman, a captain, a pilot, or a navigator. So, and in summary, it's pretty much an enterprise-grade solution for container orchestration. Okay, it's an open source system as well. It's available for anyone to view the code, to change as they need, and fork it out of that project as well. It's an extremely popular and in-demand skill. It solves a lot of complex issues that relate to containers and microservices, and that's one of the probably main reasons to why you would use Kubernetes or why would you would learn Kubernetes, because it's definitely a technology that's here to stay. In 6 years, it has achieved pretty much what no other technology has achieved in such a short period. Okay, it provides, and then we covered also what Kubernetes actually provides, and we also touched on what it does not provide. Right, so it provides a framework for you to run your distributed systems in a resilient way. That's how I would summarize it. However, it is not a traditional all-inclusive PaaS service. So it's not a platform as a service. Like any traditional other one. So it doesn't dictate certain standards of what to use or what tooling to use. It gives you the freedom to choose as you wish, and which kind of goes hands in hand with the cloud native concept. And finally, we touched on the Kubernetes architecture. So we covered the control plane that's made up of the Kube API server, the etcd data store, Kube scheduler, Kube controller manager, the cloud controller manager, as well as the Kubernetes component, the node components, where your pods are going to actually run, or your containers are going to actually run, which are mainly the kubelet, the kube proxy, and the container runtime. Again, I'll keep putting this out. It's a pretty complex system, but I'm doing my best to avoid, not being able to explain it properly. And if anyone has any questions, feel free to ask or follow up later. And you can even reach out over LinkedIn. I do not mind. I have here a list of helpful resources. The ultimate source to go for any information about Kubernetes is their official documentation. Okay, so that's why I have it in a very big font there. That's the main source for any information. Everyone reviews that. If you have been using Kubernetes for a day or a month or a year, you're going to always go to that documentation as needed and as new versions come out, because we covered this. Kubernetes is being updated pretty much every 3 months now, and every 3 months, I think on August 25th, or 2 days later, a new release for Kubernetes came out, the 1.19, with like 19 new features in stable and 18 or 13 or so in beta. I don't really remember the exact numbers, but new features keep coming out. Right? So if you wanna if you wanna use them, of course, like you have to go to documentation. No one knows all the details that's happening there, right? Another link is to Microsoft for Kubernetes learning. It's a really good resource you can go to. I've in particular linked a video by Brendan Burns. He's one of the co-founders of Kubernetes. He actually is a corporate VP now at at Microsoft for a while, and he has been working on Microsoft's managed Kubernetes as well other parts of the Azure cloud components. No one can explain it as well as Brendan would, as well as a link from Kelsey Hightower, Kubernetes the hard way. If you wanna go through the full components of the API server, or the control plane and the node components and all of that, understand how you would set these up from scratch and know what every part does, this is a great resource to go through. And Kelsey Hightower is very well known. He's a Google, he works for Google, and but he's a huge participator in the Kubernetes project, and he has a lot of presentations and documentation about, as well as books. He has written, actually, there's one book with him and Brendan Burns as well. They wrote a book together about it.
Yeah, Ahmed, sorry,
yes.
this other.
Yeah, go ahead.
Yeah, apologies. The other meeting literally. Yeah, please continue.
No worries. Welcome. Yeah. So to delve into Kubernetes API and objects, it's really important to understand these things if you're going to use Kubernetes, because it pretty much revolves about an API and using the objects. Everything is abstracted into objects, and you need to understand these components, and even from a high level before we delve into each component, because the same standard will go across everything, as well as with every upgrade, there's always a standard being followed that you should understand. So the Kubernetes API, it pretty much lets you query and manipulate the state of the objects in your Kubernetes, like any other API, pretty much. But this one is particularly dealing with objects that are for Kubernetes. At the same time, it can be extended, by the way. That's a very important feature of Kubernetes, how easily it can be extended, to be honest. Okay. So the core of the Kubernetes control plane is that API server. It's HTTP based, HTTPS to be specific for security, obviously. It exposes that users and different parts of the cluster, as well as external components like the cloud components, will communicate with one another through the API server. Okay, everything goes through that API server. So it's like a hub-spoke kind of communication. Everything has to go through the API server. Even if they want to communicate to each other, they go through that hub, which is the API server. Okay. The API endpoints and resource types and samples, I have a link, are very well described in the API reference. I have a link in there. When you get this presentation, feel free to go through it. No one will cover that, and you will always go, again, it's an important reference that you'll always go back to as you work with objects, as new features or new things are being released for these objects. You will go back to that reference. If a new alpha feature is released, it will be available for you to check there, or new beta thing, whatever. Additionally, so to make it easier, to eliminate like the fields or restructure resource representation, Kubernetes does support multiple API versions. So for that backward compatibility, and for easier maintenance of that API, and to not enforce people to actually upgrade their API, there is always that backward compatibility of some kind, and it is done through supporting multiple API versions. Okay, so even if you go to the Kubernetes documentation link I showed you in the upper right corner, probably I think that's where it exists in the page, you would have the ability to choose which API version. By default, it will be the most recent one, but you can go, okay, let's say your cluster is 1.18, not 1.19. You go to that, and then you get the exact documentation for that. So it's really well documented. It's really well structured, and you might find people till now on 1.15 or 1.14. To be honest, soon everyone will go to 1.16 because of security gaps that they need to fill. But there's always that continuous support for multiple versions of the API, and minor patches coming out. Okay, so the different API versions do imply different levels of stability and support. Okay, so you would have in general, there is alpha features as beta and stable. Okay, anything in alpha might go away. So definitely you would not use that in production. You would not rely on it. You might experiment with it in preparation. Most likely it might go to beta and then stable, but if it doesn't get a lot of traction with the community, if it causes a lot of issues, if it ends up having a vulnerability of some kind that cannot be fixed without changing the whole point of that feature, it might go away. So that's what alpha represents. Beta is something that is not in GA stability, but a lot of features actually in Kubernetes still now are still in beta, and were in beta for a year or two, but they eventually definitely go to stable features. Okay, so but they just keep it in there to make sure if any minor changes are needed or any new features need to be added to it before going to GA. And obviously anything unstable is in a stable version, and you can use it with confidence and guaranteed backward compatibility without any issues or any depreciation that might happen there. Okay. So another feature that's nice in the API of Kubernetes is they make it much easier to extend it, as I mentioned it, and they do that by implementing something called API groups in the Kubernetes API. So there are two ways to extend your API, either by using, sorry, that's my fault. Either by using something that is natively available in the Kubernetes API, which is called CRD, or Custom Resource Definitions. So it lets you to declare or define how the API server should provide your chosen resource API. So obviously you have to build some code on the backend for it, but you can natively, plug it into the Kubernetes API by using a CRD, and a lot of Kubernetes tools out there have used that, including very famous service meshes like Istio and others. Okay. You can also choose to implement your own extension to the API server and use an aggregator that you have to code fully and to make it seamless for your clients. So you have your choice there. Kubernetes, by the way, is written in Go language, similar to Docker. But a lot of these extensions can be in Python or something else. Okay, it doesn't really matter that it has to be in Go, but you have to make sure you are plugging in easily. Obviously, maybe using the CRD is the easiest way to go. The API group that we mentioned in Kubernetes are actually specified as part of that REST path in your API calls. As well as in your YAML, every object is serialized and viewed as a YAML file. In reality, it's a JSON, but to make it easier, the kubectl, there is a kubectl or kubectl client tool that's used mostly. It ingests the YAML from the client, and it translates it to JSON and gives it to the API server. So you can write your spec in a much readable way with YAML. In there, there's an API version field. Okay, that pretty much translates into a path within your REST and the API code, your REST API code. Okay, the core group is also referred to as the legacy group. Is at the REST path /API/v1. Okay, and in any spec in a YAML file, you always use API version v1. Additionally, there are named groups. There are different ones of them. So, for example, they always follow the standard of /APIs/ the group name and then /version. And in the API version, in the template and in that spec you build in YAML, it's going to be group name /version. So an example is batch /v1. In the REST path, it's going to be /APIs/batch/v1. Under there are jobs or cron jobs and different objects that are under that API group. Okay, all these states are stored by Kubernetes in etcd, as we mentioned before. Okay. Excuse me. So Kubernetes objects, they're pretty much a record of intent. It describes your cluster's desired state. Okay, and Kubernetes as a system will do its best to make sure that your desired state is always being matched by the actual status for all the objects inside the cluster. Okay. The Kubernetes objects, they would describe what your containerized application is going to run. Okay, on which node is going to run. the resources that are available to this application, so how much CPU, how much RAM I'll give it, the policies around it, how it's going to restart if it fails, like, because Kubernetes is self-healing, right? But you pretty much can program the way that Kubernetes will work, right? If you're gonna run any update on that, if it's a rolling update, how that's gonna behave, if it's gonna do one at a time or a certain percentage at a time, and so on, the fault tolerance around that. You use the Kubernetes API and the features available through it to describe that state of your objects that you want. Okay. And all your CRUD activities for any Kubernetes object have to go through that API, Kubernetes API, as we mentioned. Okay, you don't talk to the object directly, even if it's like, for example, the VMs that are running your Kubernetes nodes, or these are not, you don't communicate to them directly. You go through the Kubernetes API if you wanna, set a label on one of them or do something like that. Okay, so everything goes through the API. The object names mostly follow DNS naming standards, and they have to be unique per type, per namespace. We'll get to namespaces, but keep that in mind. Okay, a Kubernetes object is typically has two fields within it that govern that configuration. One field is the spec, and another field is the status of that object. Okay, and I think it's we have mentioned this multiple times, but the spec is pretty much the desired state that's provided at creation time, or it can be updated later, obviously. And the status is the current state that is running there, because Kubernetes is watching both, right? It's taking the spec from you as the user, or any other automation system, or whatever you're going to use to communicate with the API. And then it's also monitoring the status of that's what is currently running. And it makes sure they match. It will always make sure they match. Okay. And this state and status, they are saved in the etcd, and the etcd is like the store for that. That's why it's very important to have it highly available, encrypted as well, if there's any critical information saved on all of that. Okay, so when you create a Kubernetes object, the API request body, it must include that spec information as a JSON. But as I mentioned before, most often you would use kubectl, kubectl, or whatever you will, kubecontrol. Everyone uses their own name for it. In a YAML file, and it would convert that to a JSON for you, because JSON objects will be too bulky, and YAML is much easier for you to maintain, to be honest. Okay, and once that object is created, the system will continuously and constantly work to ensure that that object exists and that it matches the state that you have, the spec that you have provided. Okay. It will also manage every actual state and match it to that, right? So it looks at both of these. It's waiting for your input, and it's looking at what is currently running, as I've repeated. So the following fields are mandatory most of the time, probably every time. I've never seen an object that doesn't require these, which is the API version, which pretty much governs, as we mentioned, the version on the API, as well as the named group that it goes under. The kind, which is the kind of that object, whether it's, let's say, a job or a pod or a deployment. We'll get to every object eventually. The metadata, that's where you set the name of that object and the namespace where it'll live, the labels. It's generally for metadata. Obviously, you have to give it a name. You have to give it a namespace, or else it will go with whatever context you are currently targeting. By default, it's default. You should not use that namespace. You should always have your own namespaces. There is a section about namespaces. We'll cover a bit more about it. And keep in mind, as I mentioned, the name in a namespace has to be unique. You cannot use the same name for the same type of object multiple times in the same namespace, because all of these go into the DNS, internal DNS that points to that object, okay, as well as the spec and the state. It will confuse the system. Additionally, there's the spec, and the spec is always different per object. Some of them just need certain information, like a pod. It's pretty much just the smallest component, the smallest object that pretty much defines the containers that need to run, your application containers, any init containers, whatever, how much resources I'm giving them, the volumes I want to mount, all of that stuff. That's the spec of a pod, right? The deployment, which runs multiple pods, it takes that same spec of a pod that would become a template within the spec of that deployment, and then it will have additional pieces that you provide, like a number of replicas and all of that. I have a sample that I will show. Okay. You can manage your objects with imperative commands through kubectl or declarative YAML language. Okay, it's just a declarative. I'm sure everyone is aware of it. If you're not, it's just a declarative language. A lot of tools use it nowadays. For a long time, it's been used actually even by Ansible, for example, as configuration management. Azure DevOps pipelines can be written in YAML. GitHub Actions can be written in YAML. Obviously, Kubernetes is probably the most famous YAML usage out there. And it's a weird name. It just stands for YAML Ain't Markup Language. For some reason, that the creators chose to use that name. So it's weird that the actual acronym lives in the name as well. But anyways, so that's in short. And I've added a link in here for the Kubernetes API reference, again, which documents all the spec of these objects. So feel free to go through it, and you will definitely have to go through it as you learn Kubernetes and as you use it as well, because no one memorizes this. And even the official exam by the Cloud Native Foundation for the Kubernetes, there are multiples now, but the main one that started, which is the Kubernetes, the Certified Kubernetes Administrator, the CKA exam, even then they allow you to actually access the documentation. Certain URLs, you have access to that while you're doing your exam. It's a 3-hour-long exam. It's really, really difficult, but you need to practice a lot for it if you ever plan to go for that. Okay. This is a sample YAML file. This is how you would declaratively create something in your cluster. So an example here, there's like an API version, as I mentioned, that will be provided. So deployments are under the apps named group, and they are V1. Like before Kubernetes 1.9.0, they were V1 beta 1. Now, since 1.16, it has been deprecated. You cannot put in V1 beta 2. You have to put V1, or else the API server will reject that. It will not know what are you talking about. This doesn't exist for me, right? The kind is deployment. The metadata here, I'm giving like a name of Nginx deployment. The spec of the deployment, as I mentioned, it looks pretty much like this, right? So I have a selector, and it's matching based on labels. So the way this works, it will select any pods that have the label of app Nginx, and make it part of this deployment. Okay. Additionally, it has replicas, so this is telling it to run 2 at a time, and it will make sure there are always 2 running, 2 pods always. If one goes down, it will replace it. If one is not responding, it will replace it. If one is moved from one node to another, the node is being evicted, it's going down, or it's being updated, or whatever, it will make sure the other one is somewhere else. Okay. And the template is pretty much a pod spec, to be honest with you. What goes under the template of a deployment is the spec of a pod, and here is the metadata that is being given the labels of app Nginx to make sure that it will be picked up by this deployment, by the selector, and then the spec of it. Okay, I want to run containers, the following containers, which is pretty much just an Nginx container using this image and running on this port. Okay. If you come in and change this to 3, the system will add another one. If you come in and change the image to Nginx 1.14.12 or whatever specific one you want to run, it will spin up. It will update that image. And in here you can add other spec to the deployment of how it will behave with upgrading the image, or you can manually manage that and roll out your image update as you wish. Okay. So, and you can also roll back to that. Deployments are very flexible. So in here, there's, if you want to spin up a quick single node Kubernetes cluster, this is a full guide to go through. There are some prerequisites here, but if you're on a Linux system or you have WSL set up, this full installation guide does show you how to set it up on WSL. All you need to do is download the kind binary and make it executable whether in WSL or on a Linux VM. And then you can just run kind, and you can run a single node cluster. Kind actually allows you to run multiple nodes. If your system can handle that, obviously it will need more resources. And there's also Katacoda if you want to go there and practice in their in their environment that they provide. They give you also a series of things to do, like run pods, change this, deploy things, and whatever. There's a bunch of templates and modules to follow. It's pretty nice. It's good for any beginner who's getting into Kubernetes. So I would highly recommend you go through this one. I'm not sure if it's still 100% free. I know recently O'Reilly took it over. It was free. I think it still is. All you need to do is sign up now. But if someone can go through it and confirm, you might also be interested in signing up because it doesn't only have Kubernetes. It have a lot of other things. So it's pretty nice. I would really recommend to go through that. And again, this is from Kubernetes official documentation to install in your system, and then you can play around as you wish. This pretty much will run a Kubernetes cluster in a Docker container. It kind of goes against the concept of it is running a full system as a monolith in a container, but it's again for testing purposes only. Never consider that you will run any full-blown application on this. You might run your own if your system can handle it, but do not use this in an actual workplace for sure. Okay. And I just have something already running here, just to show you. So I actually have an alias for kubectl. I just make it short for myself. I use K. I'm guessing you can see my WSL, right? So I have a cluster actually running on this currently. So if I check my Docker, it's pretty much running this kind. And it's running on this port in my local host, the API server. And if I go to this, just a second, I should get a forbidden. So yeah, as you can see, it's obviously not secure because it's self-signed using self-signed cells probably, and it gives me a forbidden because I'm not authenticated through the browser. I need to get a better token and so on. But yeah, I through kubectl, I have the context running. I also use kube context, makes it easier for me. But I have my context reaching that kind test cluster that I've created. For example, as here I have some namespaces running. If I want to get the pods in all namespaces, see it's running all the pieces, running the core DNS for DNS, etcd in there. KindNet, I'm not 100% sure what that is, probably unique to Kind clusters. The API server is running, the controller manager is there, the proxy, the scheduler, and again, I'm also not sure 100% what this is for. I'm gonna guess it's to mount certain internal volumes. But you see, the main components of a Kubernetes cluster are already running. See, like the API server, control, all of these we covered in our architecture. Additionally, you see there is the control plane and the DNS also running. So you can do pretty much anything you need here. Creating any like external load balancer, that will not be possible. So if you want to expose services in Kubernetes, we will get to that piece. But usually you can expose an external service on a public IP or a private IP. So that's not going to be possible here. You have to have a cloud environment. So you can deploy an AKS cluster and go ahead with that. I will get to AKS for sure, but I'm trying to cover all the core components of Kubernetes in general.
Ahmed,
Yes.
quick question. On this system that you're running in WSL,
Yeah.
can you actually take a very small pod and deploy it into this?
Yep. I'll just keep it in default.
No, I'm just asking a question. I don't want.
Yeah, you can.
Okay, and the second thing is that can you actually do a bind mount from your Windows system into this cluster?
I'm not 100% sure. You need for mounts like that. Most likely you will need WSL2, not WSL1. I currently have only WSL1. I'm not 100% sure if it has storage classes. I'm not sure if it's gonna be able to mount something from your system. I'm not 100% sure. I haven't used it extensively. Again, it's only for basic testing. If you wanna get used to Kubernetes objects, things like that, right? Basic stuff. But if you wanna go full-blown deployments, I would definitely recommend to go with an AKS cluster for more advanced features. Okay, because AKS will give you Azure Disks, Azure File, all of that. Okay, so if you see, I just deployed Nginx. I have an Nginx pod running. Yeah, so you can run pretty much anything you need. I'm not sure if it's already exposed. It should be, by like, I mean, I cannot expose it with a service, but you can use this. My recommendation, purely use this one to familiarize yourself with the Kubernetes objects. Okay, that's pretty much what I would recommend. If you want to do anything full-blown, deploy actual applications that need an actual external storage, that need an external endpoint to test it fully, I would definitely recommend an AKS cluster. You can get free credits and go ahead with that.
Okay, thank you.
No problem. So I'll go back to the presentation. I'll go back actually to WSL, but these are very important. I would really recommend these. Just a second, sorry. I would really recommend these commands. This will be very helpful, especially when you're starting to learn Kubernetes, as well as your day-to-day activities. If you want to get a quick information without going to, go through the browser and look things up or whatever, everyone always go through that for sure. But this first example, this pretty much does not actually create if you saw me, I just created a deployment, right? But in here, I can do a dry run and output it as a YAML. So you saw the sample that I shared with you. You might forget that. You might forget some indentation. You might forget certain things. I would do this, for example, right? So create deploy engine, or actually I already had the command, right? So in here, I will just add dry run equal client, and I do output YAML. So what this is going to do is going to actually give me a template. Okay, it's not going to deploy anything. I can copy this. Obviously, I can redirect it into a file and manipulate that as I want. So nginx.deploy demo. So in here, I have my template. I can alter it as I want. I can add my labels. It has the correct indentation. Obviously, you would delete this will not really make a big difference, but you would delete like the creation timestamp, this one as well. The status you would delete because you don't provide the status, it gets picked up. You delete this one as well, but in here you can add like, okay, I want to add ports now. I want to change the labels or add something to it. Strategy is relating to the strategy of how your rollout would happen. I want 2 replicas instead. I'll make this 2, and I will change the image to something else, and then I can use kubectl apply and use it on my file, and it will deploy that for me based on whatever spec is described in there. It's extremely helpful to come up with short YAMLs, or if you're having any issues, or if you want to deploy something small but you want to keep the YAML that you have deployed, I would recommend to go through that. The other helpful one is the kubectl API resources. So I will show you that because it's really, really helpful. It gives you a nice summary of all the resources I have. Okay, it tells me if they are namespaced or not, the API group they live under. So now I know that this is the API group that I would use here. Okay, the short name, because if you noticed, I do deploy. I don't put the full thing. I don't have to put the full thing. I can do deploy. It actually translates to deployments. PSP for post security policies. But there is a lot of, not everything has a short name, but a lot of them do have a short name. Obviously, if you start managing clusters daily, this becomes very helpful. Get SVC instead of typing service. I just do this, right? And I think in here you can filter, for example, namespace. I think so, equal to. Yeah, so this will give me only the things that are namespaced. Not everything is namespaced, obviously. I can also do the same thing for false. Okay, so everything that's not namespaced, because you might build a template by the assumption that everything will always be in a namespace. I will add it under the metadata, and then the system is rejecting it. Like, you should not give this. Then, you can use this to confirm that you're actually, sorry, just a second, that you are actually using the correct spec that needs to be done, or also the API group. And this also gives you the kind that you can put in your template. So this is very, very helpful. No one memorizes all of this. And by the way, like even the CRDs, things that are a CRD and they are extended to the system, they will show up here. So let's say I install Istio, it becomes available to me a part of the Kubernetes API. I just communicate with the API because that's the type of object that's now available. I can list it here. I can know everything that's for Istio, right? And I will know their API group. I will know the kind that I need to use, and if I want to manage them quickly, I will know the full name, the short name, and whether they live on a namespace or not. It's extremely helpful. I would really recommend to get used to that one. And the last one is the kubectl explain. This is pretty much in kubectl. You have a full documentation available here. So if I do explain pod, it will tell me all the fields that are needed or available under that type, right? So tell me this is the kind, this is the version. Now I can build a template out of that, right? So all I need to put is version 1. If I do deploy here, for example, well, the version is apps/v1. The kind is deployment. Okay, so this helps me building the template. I could use the dry run, but then I need to figure out other things I want to get, right? So I'm looking for deploy.spec. Okay, what's under the spec? I can see that as well, okay? With the description, it gives you details. The defaults sometimes will show you actually what the value can be, what the value would be as a default. Okay, I can look, for example, okay, spec.replicas, okay? So, that's a specific one. You will know if it's an integer or a string or whatever. All the documentation is accessible through this simple command, and you can delve into each and every part of that. This is extremely helpful. Okay. So one more thing you can do is get the raw API. So if I want to do, like let's say here, I want to look at /API/v1. Okay. I'm gonna pipe it through JQ, for example, to make it a bit more feasible because it's a JSON. So this is pretty much showing me everything that's under the /API v1, all the things that are available for me. Okay, and this is mostly extremely helpful when you're building custom RBACs within your cluster, any role-based access control. You would want to know also what I can run on it. Is it the get command? Is it the patch and update? What can be done on every piece here? Okay, so, and if you're interested in a specific resource, you can use just JQ. So all of these are under resources one. So if I do this, I think so. There are an array of resources, and I want to select, for example, pods. Okay, so now I have specifically the pods. Okay. It's very helpful, and now I know that if I want to build a custom RBAC for people to, let's say, they can only get and list pods, okay, or watch pods. They cannot do anything else. I will not give them the delete or create or delete collection, which allows them to delete a full group of that. Okay, so it's extremely helpful to also look at this. It can be very, very bulky, but you can always manipulate it with JQ or any other tool of your choice. Okay. So to go back to this, so Kubernetes namespaces. Kubernetes pretty much supports multiple virtual clusters that are backed by the same physical cluster. Okay? These virtual clusters, in short, are called namespaces. Okay, so the names of, again, as I mentioned, the names of resources need to be unique within a namespace per type, but not across namespaces. So if in one namespace, I have a deployment called Nginx, in another namespace, I can have another deployment called Nginx. Obviously, that's not a good practice. You typically would name that because, again, a namespace generally would reflect environments or whatever structure you want to use there. But typically, you would also use the deployment names, or your object names should follow that standard. Okay. It's mainly intended for use by large teams to share the same cluster. Okay, even if it's a small team, but you want to use one cluster, you have some limitation from a physical host perspective, or you don't want to go through the hassle of creating multiple physical clusters. You're okay with one non-production cluster, and within that I will have my development environment, my QA environment, my UAT environment, whatever you want to build as environments within the same non-production cluster. You would typically put these in different namespaces because you might have different teams accessing different ones. You might have different different requirements in each, different deployments in each. From a security perspective, you can isolate these from each other. You can also, you have different resource utilization in each. You can also give each one of them different resource quotas. So it's intended for use by, as I mentioned, by large teams for the same cluster. It provides a scope for object names, but not all objects are namespaced. Keep that in mind. You cannot nest one namespace into the other. Okay, most objects like pods, services, deployments, all the stuff, they are in some kind of namespace. They are namespaced, but namespaces resources are not in a namespace. Nodes are not in a namespaces. Like low-level stuff like nodes, persistent volumes, which represent your storage, also are not in a namespace. So again, the command I just shared will help you identify these things. Okay. One important thing to know, every resource can only be in one namespace at a time. You cannot have one object live in two namespaces. That's not going to work, okay, because namespace goes in. Yes.
Ahmed, again, you said that persistent volumes cannot live in the same name. I mean, are not limited to one namespace. Is that what
persistent volumes are not namespace. As an object, persistent volume is not namespaced. Persistent volume claims on that persistent volume are namespaced.
Okay. So the persistent volume claims in different namespaces can, ask for a claim on the same persistent volume?
If it allows read-write many or read many. If it allows.
Read-write many would be, okay. NFS would definitely
yes,
allow that.
NFS. Azure Files is a great one to use. So in AKS natively out of the box, it allows you to create that easily. It has already a storage class that references that. So all you need to do is just create a claim on that, and it will automatically reference it through the storage class.
Okay, thank you. I didn't know that persistent volumes can be non-namespaced. Okay.
Not can, they have to be. You cannot create a persistent volume in a namespace as an object. The claim lives in a namespace, yes. It has to live in a namespace and used by resources in that namespace.
Okay, thanks.
Okay, no worries. Each resource, as I was mentioning, can only be in one namespace. You can set and should set resource quotas on every namespace if it's shared by multiple teams to avoid fighting. Okay. Sorry, excuse me. And again, the command I referenced or I shared before will help you a lot to identify what is namespace and what is not. It's really important to know that ahead of time. Do not, this is a mistake that a lot of people might fall into, especially if they're new Kubernetes. Do not use namespaces to separate things that are slightly different. Okay, slightly different resources should not be separated just by using namespaces. Okay, so I'll give you an example. If you want to deploy same resource, okay, but there are two different versions of that resource. Okay, you would use labels to distinguish that. You would not use namespaces. Okay, that is not really a good approach. I'm not going to create a new namespace just because I have a new version of it. If it's a QA image and a dev, yes, I understand that. But in dev, I'm working on multiple versions on multiple things. I would not have a different namespace for that, for sure. Okay. And namespaces this is very critical. They are a part of the internal DNS of QDN. Okay. So I'll give you an example. If you run a service in a namespace, the DNS entry for it would have the form of service name .namespace name .svc.cluster.local. It's always going to be svc.cluster.local, but it will always have the first subdomain as service name, then namespace, which means in the same namespace, I will not be able to have two services with the same name. That's not going to work, right? But in a different namespace, I can have the same service name. That's okay. Okay, so it will resolve to that service, which is local in that namespace. And anything within the Kubernetes cluster, as long as it has access to the Kubernetes DNS service that is running, it will be able to resolve that FQDN and go to that service. Anything external, you would build an external kind of solution to map to it, like an ingress, like a STU service mesh, or whatever you want to utilize in there, or an Nginx ingress controller. Okay. So it's very useful to use the same configuration but across namespaces. So if you want to, have parity, and you should have. This is another, again, like another cloud native or another best practice from a development in terms of cloud native solutions is to have that parity between your environments. So if you're developing something for a namespace for development, you're deploying there, and you're deploying in staging and production, you would want to have that same parity. So this allows you to do that, but the only difference would be the namespace name, right? But the service is the same everywhere. Okay. And as I showed, the Kubernetes starts initially with 4 initial namespaces, which is a default namespace. Anything will go in there unless you choose a different namespace for it. Kube system, that's where the objects that are for the Kubernetes system. Do not use that for any deployment. I highly recommend not to touch that one, especially if you're running a managed service. You should not do anything in kube system. Kube public, it's automatically created. It doesn't really mean that it's public. It does mean that it is readable by all users, including ones that are not authenticated. It's reserved for cluster usage. I would also recommend you don't use that. So RBAC policies do not apply to that. So anonymous access to read things in there would be feasible. I highly recommend you do not use that for sure. And obviously, you should build your own namespaces and whatever makes sense for your deployments. Okay. A few other, pointers that are important from a Kubernetes management perspective in general are Kubernetes labels, selectors, and annotations. Okay, so labels are key value pairs. They're attached to every object, and each key must be unique for a given object. You cannot use the same key multiple times in that object, in that spec, as we were looking at it, right? So it's intended to be used to specify the identifying attributes of that object. Right? They need to be meaningful. They need to be relevant. And the selector is made by multiple requirements in there. Okay, you can put multiple requirements. So it can be a set of it can be set at the creation time of the object, but it can also be added later or modified. It's part of the metadata, right? So it's up to you to do that. And usually, it allows the users to map their organizational structure to these system objects, right? So let's say these objects are, and you label them by environment, you label them by application, by project, whatever you see fit. Things that map your structure from an organizational perspective, and you will utilize them because the label selector. The selector pretty much is a label selector mostly. Okay, it's the core grouping primitive in Kubernetes, so it allows the user to identify these objects, as well as the API, by the way. As we saw in deployment, the selector will look at the labels on these pods and will know these belong to me as a controller. A deployment is a type of controller on Kubernetes, right? So they're very important, and you should plan them ahead of time. Okay. There are currently 2 types that are supported. There's equality-based and there's set-based. There's always a logical and between. You can provide multiples. There's always a logical and. Okay. There is no logical or. So you should build your things, your structure around that. And equality is pretty much equal to or not equal, things like that. Set-based is, it supports operators like in or not in or exists. So exists will work only on keys. You wanna base your selector on that this key exists on this. So regardless of the value, if the key exists on this one, this key of the label exists, the app key, for example, exists, this is gonna be selected, right? Or if you give it a list of values, and if it's something in that or not in that, it will be selected. Usually you would mostly use equality. I haven't seen set-based used much, but there are maybe unique cases. And some typical and recommended labels are app, version, environment, components. These are things that I would recommend you use. So that's something to keep in mind. They're very efficient and would help a lot with your queries and as you're watching things. and you can set them even on nodes. Like selectors can be on nodes to make sure that, okay, these deployments will run only in these nodes. Let's say you have a node that has a GPU and you have deployments that require GPU, you would make sure that they will run on that node specifically, right? So you can also build your own structure to make sure fault tolerance is there, and if you don't want to trust Kubernetes with that, right? When it comes to annotations, that's another thing that can be added in the metadata. You usually attach any non-identifying metadata to the objects, timestamps or releases, or you want to put your branch number in there, the PR number, whatever you want to do. Put that in an annotation. Don't put that in a label, because it's not really something that is structure or organization wide that would define how things would look like. I think there's around 10 minutes left, correct, or a bit less. So I'll maybe leave this part to the next presentation and open it up for questions. If anyone has any questions, or if there are already any questions available on because the piece about pods, I have multiple slides, and I would like to cover them in details, because it's very important. So let me look if there's any questions that are there.
There is one question from Turhal Ahmad. Can you see the objects related to namespaces?
If you can rephrase that, I'm not sure 100% I understand the question, if Turhal is still there. Do you, sorry, just a second. That I might know what he means. So do you mean like you want to look at the objects that live in a specific namespace? Let me open that. Okay, yes, definitely, yes. That's a very core piece. Yeah, it's a great question. This is very important. So you can, when I'm getting objects, okay, let's say I want to get the pods, I want the pods in the cube system, okay? It will give me the pods that are only in the cube system. If I want in all namespaces, I can give all namespaces. It will give me all the pods in all namespaces. As you can tell, when you get them, you always get what the namespace is. Okay, you can ask for more information. You can query this. There's jQuery that works with this stuff, and to filter it out. But yes, you can get that for sure. Yeah, as I mentioned, you list them by providing this field. So if you're using kubectl, you add the -n or -- namespace and the name of the namespace where you want to get it. Or you can list, this is specifically for pods, okay? If you want to get all objects, you can do this. All objects and all namespaces. It will give me a lot of lists here. So it gives me all the pods, and then all the services, and all the daemon sets, and so on. Or you can list a specific, as I mentioned, specific object type, which is pod, and in all namespaces or in a specific namespace. So then, no problem. Welcome. No. Yep. But keep in mind, because kubectl will work on native Kubernetes cluster, like native objects. If there's any additional object that has been added, any CRD extended, the all will not cover that. All will give you like pods, deployments, services, which are essential. You always will have these daemon sets, things that are part of the default Kubernetes API. Because it's being pretty much handled by the kubectl client. So that is not updated to you what your client have. It can query the API server for additional things that are there, any CRDs that come out, but it will not have will not cover everything. It will only cover the basic ones. Any other questions?
Looks like no other questions, Ahmed.
Okay. Well, thank you all for attending. Hopefully it was helpful. If you have any follow-up questions, feel free. I will share the presentation shortly with the team, and You can feel free to go through the links I've shared to delve more into the objects, and in the next presentation we will definitely cover more details about the objects themselves or the workloads that can be deployed into Kubernetes.
Awesome.
Okay.
Ahmed, just a quick comment. There's a person who is joined with the name VD. I don't know who he is. If you wanted to unmute and say, and also Aishwarya Ravi, you have joined from your Office Teams account, I think, directly clicking the link in the Eventbrite, which is good. But if you wanted to have an alternate account directly from the Testoper community, please send your email addresses. We will add you in, so you don't mix with your Office account to Testoper community account, because it's critical, right? And at the same time, you can also, when you have an access to the teams, you can also have access to many things, many collaborations that we do. And in case if in future you have questions with Ahmed and things like that, you can ask Ahmed questions in the Codeathon channels or in the chat that belongs to that particular intelligent automation Codeathon chat group, right? So one of there are many facilities for you guys to join that. I just want to make sure, in case if you have you don't have an account, send it to us. Your email address will add you, and also there is a WhatsApp link for the closed group WhatsApp link, in case if there unavoidable reason, if you have to cancel the session and things like that, we normally inform through that. So please join that also. The link is available in that chat channel. Apart from that, thanks for joining, everyone. Please help us to spread the news and get most of the people to come and take benefit from this. Ahmed, from your session, third session I'm attending, again, awesome. What else can I say? I mean, excellent sessions. I'm very happy. I've been learning a lot from you as well. So with that, if any programs teams or anyone has anything to say, if not, we can close the call. You guys have a great weekend. Enjoy yourself. I'll see you on Wednesday on Test Automation track, or next Saturday in the IA track. Take care. Bye-bye.
Thanks, Ahmed.
Thank you. Thank you, everyone. Take care. Bye-bye. Bye.